Hello and welcome to another video. In this video we're going to be doing Champagne Tower. So this is actually kind of a cool problem because it's kind of different than most other problems. So essentially in this problem you are stacking glasses in a pyramid where the first row has one glass, the second row has two glasses, and so on. And each glass holds 1 cup of champagne. And then some champagne is poured into the first glass at the top. When the topmost glass is full, any excess liquid will pour evenly into the glasses to the right and to the left of it. When those glasses become full, any excess champagne will fall equally to the left and to the right of those, and so on. And so at the glass at the bottom row has excess champagne fall to the floor. For example, after 1 cup of champagne is poured, the topmost glass is full, so this one here is full. After 2 are poured, these 2 are half full because it splits equally. Then after 3, these 2 are completely full. And after 4, this is the excess, so these 2 will both pour into here. So essentially you have one excess glass, so it'll be like a quarter comes from here, 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 but because this one has 2 quarters, this one will be a half. And so then you can query any row you want. So here are some examples. So you have one poured glass, and you are querying row 1 and query glass 1, and it's 0 index, so this is going to be this glass over here. So after 1 glass, this is full, but everything below it is empty. So let's actually draw some of these to actually explain this as well. So we're going to draw some glasses here, and we're kind of going to show kind of like what's happening. So let's just draw this for now. I know it's a little, actually, got a solution here. We can just do this instead. So they are actually even for once, sort of. So here we go. So if we pour in, let's say, 2 glasses, then the first glass will come here, and then the second glass will be distributed equally this way and this way. So these will each have half a glass after 2 glasses. But this one asked after 1 glass, what is in this glass over here? And so this will be 0. So for the second example, we have 2 glasses poured. So after 2, it's going to be like this, right? And then they ask for some super big number that I'm not going to obviously demonstrate. So the problem with this problem that makes it kind of hard is you might think, like what would a brute force solution be? Well, a brute force solution would be just like manually pouring every glass and simulating that glass being poured all the way down until you have nothing left. But the problem with that solution is this number is really big, so it's 10 to the 9. So even like a linear solution wouldn't work there. So we can't really pour every glass. Instead, we have to do something which I think is quite tricky, to be honest, but let's kind of demonstrate this. So let's just draw a bunch of these. So we have one here, and one here, and then we will draw 4 more. So quite a lot, just to demo some kind of situation. So yeah, if you do 1 glass at a time, it's kind of tricky because you're like, okay, well, let's just go through a few of these. Like this will be 1, then the second glass will be like, these will be a half, and then the third glass, these halves will become 1s, and then the fourth glass, what would happen is like, it would go like this or something, and so on. And I was trying to like find some kind of pattern here where like you just pour glass by glass, and it was really hard to figure out like how can I just figure out how much will be in some glass after some pours, and like what's the pattern. Maybe there is one, but there's actually an easier way to do this, a lot easier way to do this, and I'm going to kind of show that here. So instead of focusing on like what happens after every single glass pour, we can just put in a big number into the top one, and then for every overflow, we can just pour down. So let's kind of show how that's going to look. So let's say we pour 7 glasses. So what we're going to do is we're going to pour 7 glasses, and then we're actually going to say like how much was poured, like what's the total in here, and then how much is excess. So in the top left, I'm going to show how much was poured, and then the bottom right, I'll show the excess. So we pour 7 glasses. And we pretty much know if there's excess, that means this whole thing is filled up, right? So it can get filled up by 1 total glass. So what happens is if we put in 7 here, we will have 6 excess, right? We can get 1 glass maximum. So we're just going to pour all 7 at the same time and keep track of the excess we have instead of trying to pour 1 at a time, and that will bring down our complexity a lot. So let's kind of show what that would look like. So for these 7 glasses, we have one glass in here. We can even show like the one here if you wanted to. And then we have 6 excess glasses. Now where do these 6 excess glasses go? So they go equally into each one of these. So we have 3 here, 3 here. Now they each take 1 glass, and we have 2 excess for each, right? So this makes sense, right? These 3 are filled, and we have 4 excess glasses. So far it makes sense. Now, the way these split up is like this. So let's just take this one first. So this one has 2 excess glasses, right? So it's going to split it equally between both of these. So in this left one, there will be 1 glass. And in this one, there will be 1 glass. Now, this one also splits these equally. So it'll put 1 in here. So now this 1 gets another 1. So now this becomes 2. And now this has 1, right? It splits these 2 equally. It goes left and right. So now we have something where we have 1 glass, 1 glass. We have 0 excess here and 0 excess here. But here we have 1 glass and we still have excess. So we have 1 excess. And where does that go? Well, that goes equally between these 2. So it's going to go half, half. And now this row down here, because we didn't pour anything into the other ones, would look like this. And so let's count up our glasses just to make sure we did that right. So we had 7, right? So we have 1, 2, 3, 4, 5, 6, 7. So we did it right. But that's essentially what you have to do is you have to build a row. Instead of trying to do 1 pour at a time, you just put the whole number in here. So we'd put like 7. And then when we want to find out excess, it's really easy, right? The formula for excess will be whatever the total is in the glass minus 1, right? So because the glass takes up 1, and if this number is positive, right? Like obviously if the total is like 0 minus 1, if this number is positive, we split it equally between the 2 glasses to the left and to the right. So it's the total poured into the glass minus 1 over 2, assuming this is a positive number. Obviously, if it's not, like, right, if we pour in like half a glass and there's going to be no excess. But assuming this number is positive, then we will divide by 2 and just pour into each glass. And so what it's going to look like let's say for this row here, let's actually demo let's actually demo what this would look like row by row now. Let's actually bring this up, and then we can code it up after that. And notice how every row relies on the row directly above it, right? So this row relies on this row, and then the row, and so on. So instead of building up this whole thing, we're actually going to save up a ton of space, and we're just going to make like an initial row, and then the next row down. So I'm going to kind of show you how that's going to look like and walk you through it. So we're going to have like a current row, let's just call that C, and we are going to initialize that to be an array of just this one row and then whatever glasses they put in here. So let's say they put in 7 glasses, so it'll look like this. Then we have a new row, and every time we make a new row, we will just take the length of the current row and add 1 to it and make it all zeros. So it's going to be 0, 0 as our new row. Now, what we are going to do is for every single number in the current row, we're going to check for the excess. And we also, we keep doing this until, so let's say here we have some queries. Let's say we're looking for this glass here, right? We're looking for this glass over here. This is row 0, 1, 2, 3, and glass 2. So essentially, how many new rows do we have to make to get here? We have to make query amount, right? So essentially, we just do this query amount. We get the new row query amount of times, and then our final row that we made is going to be the query row, and we can simply index the column in there. So let's kind of walk through that, right? We have to do this 3 times. So what we're going to do is for every single thing in the current, we're going to say, okay, how much is the excess? So the excess here would be 6, and you want to divide it equally between its 2 children, right? So that would be divided by 3, so that would be, you want to divide by 2, so that would be 3 into each cup, right? So like I showed here. And what indices does it need to go? So I'm going to index these as well to make it easier. So this is index 0, index 0, index 1. So if you notice, if I actually index these as well, like this, you're going to see a pattern here. So if you notice, whenever a cup is being poured into 2 children, it's always the same index as that and the one after. So 0 goes into 0 and 1, 0 goes into 0 and 1, 0 goes into 0 and 1. Now 1 goes into 1 and 2, 2 goes into 2 and 3, 1 goes into 1 and 2, and so on. Right? So the 2 indices this is split upon are its current one and the one after. So let's just kind of draw this out. So there is an excess of 3 that goes into each one of these. So these become 3, right? Let's actually use this color. These become 3 now. And now this, like we did this once, but we have to do it 3 times. Now we just simply say, let's make our new row our current row, right? So we're going to get rid of this row over here now, completely delete it. And this is going to be our new current row. And so now we have to do this 2 more times. So we're going to make a new row again. And it's just going to be 0, 0, 0. Now we have to walk through all of these. So the indices of these are going to be 0, 1, 2. So for this one, there is an excess of 2 being split equally, right? So 1 needs to go here and 1 needs to go here. So let's do that. So we're going to put in a 1 and a 1. Change the color here, right? So there's an excess of 2 because this cup takes 1, and then there's 2 more, and it needs to be split equally. Now for this one, there's also an excess of 2, and it needs to be split equally, remember, into indices 1 and 2. So 1 already has 1, so this will add another 1. And now this one will get a 1. So we did that twice. We're at this row. We need 1 more of these. And remember, now our new row will become the current row. And then our current row is gone now. So we're essentially just swapping the current, like we're making a new row and then we're setting the current row equal to it. And then we keep making a new row and so on. So we're only using a very small amount of space, right? We only have 2 rows. So that's pretty much constant space. We can probably do it in 1 row if we wanted to, like in place, but it's kind of unnecessary. Okay, so now let's make another new row. And once again, same kind of thing, right? So it's going to be the length of the last one plus 1. There we go. And this is going to be index 0, index 1, index 2, and index 3. Now let's check the excess. So for this one, there is no excess because a glass, like this will just take the full 1, right? Now for this one, there is an excess. There is 1 excess, and it will get split equally into 1 and 2. So these both get a half. So this is 0.5, and this is 0.5. And here there is no excess either because, you know, the glass will take 1, and then there's nothing after that. So here's our result for the row that we care about, right? So if we cared about row index 3, we'd do this 3 times. We make this the current row. This row gets deleted. So this row is current. This row gets deleted. And now we actually have the row we want, and simply we just take whatever the glass index is. Let's say in this case it was 2. We would just return 2. And that would be the answer. Now there is another thing. So we did save a lot of space doing it this way, right? Where we just have the current row and the new row, because we recognize our new row only depends on the row above, so we don't need to store this entire pyramid thing. We do have one more trick that we can use, and that is for every row that we make, let's say that, like here, for example, let's say we make 1 more row under this. So 1 more row under this one. Let's say we got the query of that, and let's say our query was like row 99 or whatever it is. So here we would have 0, 0, 0, 0, 0, right? One more cup, and none of these have an excess, right? Because none of these are over 1. So as soon as we get something that's all zeros, we can just break right away and return 0. Because we know that, like, there's no point in going further down. We can actually technically, no, I guess we don't want to do that if it's 1s, because that might be the current row we want. But if we get something with all zeros, there's no point in building more rows, right? Because if we have nothing left, it's just going to keep being more nothings. So that's another thing. We can early terminate if when we try to pour down, there is literally nothing left, right? So like in that example, if in this example, let's say it asked for, you know, this like row 33, but then instead of poured being whatever this number is, like 10 million or something, if it was like 10 or something, right? We would just fill up some rows and then we'd run out of like alcohol to pour into the rest of them. So there's no point in doing that. So we're gonna use these 2 tricks. We're gonna have a current and a new row, just so we don't have to store this whole pyramid, and we're also gonna early terminate when there is no more alcohol to be poured down, because it literally would just continue to be a bunch of zeros. And that's essentially what we're gonna do. And now let's code it up. Full screen. So we're gonna start with a current row, right? Just as I showed you in the picture, and that's just gonna have 1 element, and the amount of alcohol will be poured in that. And now we are just gonna loop query row times, right? And we don't really need this I at all. We're not going to use it. So for this loop, we're essentially going to make a new row. So it's going to be new row equals 0 times the length of the current row plus 1. We're going to make one more element. And now we are going to make an element called empty, and we're going to use that. Or you could get the max of your row. Either one's fine. So I guess, yeah, you could technically just get the max. I guess we could do that. So, instead of doing that. So essentially what we need to do is we need to loop through our current row. So for I in range, length of current row, we need to check, is that value greater than 1? If yes, we have access. So if current row I is greater than 1, then let's actually, I guess actually, let's have an element here. I think it would be a little bit faster. It probably doesn't matter too much, but this is fine. So essentially, this will check for if the entire row is empty, right? So if current row is greater than 1, then we need to figure out the extra. So extra, and the reason we need to do greater than 1 because there's only excess if this number of alcohol in the glass is greater than 1. Otherwise, there is no extra. So extra equals, like I said, current row I minus 1 over 2 because the cup will take I, and then the rest is divided by 2. And where do we need to pour that in? We need to pour it into new row I. And we also need to pour it into new row I plus 1. So we need to pour it into both of those. Extra. And then we set empty to false because we do have a cup or a glass in our new row that's not empty. But if we went through this whole loop and we never had a glass in our new row that's not empty, we can just return 0 right away because we know that this whole new row is going to be empty. So every query from here on in will be 0. So we can just return 0 here to not have to go any further. It's empty, return 0. And now we just essentially swap our rows. So we say current row equals new row. You don't need to make a copy because we are going to make new row like a whole new row. So it's not going to like override it or anything. So that's not a problem there. So you don't need to make a copy. Now, finally, when we do that, so once we break out of this for loop, we're guaranteed to be on the row of the query string or of the query because essentially we're doing this query row a number of times, right? So if this was like row 3, we'd make 3 new rows and then we'd be on the one we want to be. So now we do want to return current row, and we need to return just index at query glass. But there is one more thing, and that's like let's say there are like 100 glasses, and you're asking for like row 1, column 1. The problem is this number will have like a really big number, right? It's not going to have 1 in here. But realistically, anything over 1 gets poured down. So the max number we should be returning here is 1. So we can just min that with 1 to make sure that we return 1. Because this can have a bigger number than 1, but in the realistic scenario, if this had like 80, the rest of it would just pour down into something else. So we want to return maximum 1, and we want to return maximum 1, and if this number is below 1, it would return this instead. So now let's try to run that, see if we have any errors. We do, let's see here. New row, misspelled. Okay, so I think we're good. Let's get rid of this now and let's run it one more time. Let's take a look. So it looks like it's accepted and it looks like it's submitted, and you can see it's very efficient because we had that early break and we also were using a very good amount of space. I think you can probably do it with like 1 array or something, but it really doesn't matter. 1 array or 2 is still constant space technically. Yeah. Well, I guess it's not constant because it still has like there's still a query glass. Essentially, it goes from query glass times query row into just query glass, right? So let's go through the time and space for this one. So what are we doing, right? We are going all the way down into query row, which is going to be worst case scenario, whatever that query row is. Let's call that row or something, right? However many rows. For every row, we're making a new row. And what are we doing in the actual loop itself, right? So we're making a new row. It's going to be length of something. And then also for every single row, we're going through every glass right? So that's going to be like row times glass, because essentially we're creating a new element every time. So we have basically a nested for loop where we're going through every row, and then we are also getting every single glass. So it's going to be something like that, but the nice thing is these numbers are small. These numbers are only 100, so it's like 100 times 100. And we really wanted to avoid going glass by glass, because that is the thing that would cost us a lot. If we try to simulate a glass pour at a time, then we would get a time limit exceeded because it's way too big of a number. So that one is that. And for the space, we are essentially making a current row and a we're making a current row and a new row, and this is just, we only have one of each, so that's basically O1 for the rows. So this is going to be dependent on the number of glasses in the current row, right? So you're going to keep making new arrays, and the biggest one is going to be whatever your query row is, and that's going to depend on this query glass number. It actually doesn't really depend on the query glass number, but it more depends on... Actually, now that I think about it, I think it actually this would actually depend on the row, not the glass number, because every row gets an increasing 1. So the number of glasses is technically... So I guess honestly, this would also be yeah, I think you can simplify this down to row squared essentially, because the number of columns in every row is the row you're on, kind of, right? Like it's like 1, then 2, then 3, then so on. So for every row, max you have row number of columns essentially. So I think this is row squared, and this is just O of row, because the number of columns in a row is like the index of the row. So it depends on how many rows you have. But yeah, I think it's going to be something along of this sort. And we definitely did save it, because if we didn't use 2 rows, this would have been row squared space. If we made that whole pyramid, it would have been something like row squared, because it would be like 0, 1, 2, 0, 1, 2, 3, 4, 5 or something. And if this was 5 rows, then it would be like a 5 by 5 essentially, worst case scenario. So it wouldn't be exactly a matrix, but that's what it would be. So we're essentially saving a dimension here, which is nice. But yeah, it's going to be all for this problem. Definitely an interesting one. And it is tricky to figure out that you can simulate this glass pouring. I was definitely trying to figure out like some kind of shortcut, and like seeing if I could just figure out how much glass is in a glass based on like how many pores there are, but there really aren't. So you basically have to simulate it. But they do kind of give you a hint, because they tell you that you can't really simulate glass by glass because this is way too big, but the actual rows and columns are pretty small. So if you could somehow figure out the excess, then that's totally doable to simulate the whole pyramid. Yeah, I think that's going to be all for this problem. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.